right, I just have 3 examples here that we're going to work out for hyperbolas. And as always, I encourage you guys to pause the video first and try them on your own, and then unpause it to see the solution. So hopefully you've paused it, tried it out on your own. Here's the solution for the first one. And just like with ellipses, we have to put it in standard form first, which means making this side equal 1. So I had to divide both sides by 36 first. And when I do, I get this. It all simplifies down. Now I can see that my x term is positive, so that makes it horizontal. I can see that a squared is 9, so a is 3, and b squared is 4, so b is 2. Using this equation to relate a, b, and c, we can find that c is root 13. And then also because there's no x minus or plus something or y plus or minus something, we know the center is at 0, 0. H and k are 0. That gives us all we need. So I just started off with my axes. The center is at the origin, 0, 0. I go left and right a units. So a was 3. I go up and down b units, and b was 2. And then root 13 is in between root 9 and root 16, so it's between 3 and 4. So just estimated where f1 and f2 go. And then I can go ahead and put my vertices down. And it's horizontal, so my vertices are going to be horizontally aligned. So it's all going to be about a, the horizontal distance, measured from h, the horizontal coordinate for the center. So 0 plus or minus 3 gives me plus or minus 3. And then the foci are at 13, so 0 plus or minus root 13 is plus or minus root 13. And then the transverse axis is going to be 2a, which is 6. Boom, there you go. That's example 1. So let's look at example 2. All right, here's example 2. And again, as always, I encourage you to pause the video and try this on your own. And now we'll go ahead and take a look at it. All right, so here we go. So the problem did give us the foci and the asymptotes, and we're supposed to come up with the equation. Well, we know that the midpoint of the foci is going to be the center, and we can see that the midpoint of the two foci is going to be at 0, 0. Also, if you think about plotting the foci, they're going to be vertically aligned from each other. Excuse me. And so we know that this is going to be a vertical hyperbola. Remember, that's going to tell us that the y squared term is positive. So we have that. Okay, so c is the distance from a focus to the center, and we also now know that c is 10, because each one of these points is 10 units away from the center. So we know a lot just by looking at these 2 points. We know that the center is at 0, 0. We know this is going to be a vertical hyperbola, and we also know the value for c. Now let's take a look at what we know from the asymptotes. We know that the slopes of the asymptotes are always going to be plus or minus b over a. And we can see that the slopes are plus or minus 3 over 4. So it's going to be very tempting to say that b is 3 and a is 4. But is that true? Remember, this equation has to be true. A squared plus b squared has to equal c squared. And a is 4, we think. B is 3, we think. But we know that c is 10. If you go ahead and work this out, you don't get a true equation. 16 plus 9 does not equal 100. So, what's going on? The key is that b over a is 3 to 4, but that doesn't mean that b is 3 and a is 4. It means that the ratio of b to a is 3 to 4. So what that means is b to a is 3 something over 4 something. And that's something, you just pick a variable for it. I just picked r for ratio, but you can pick whatever variable you want. But it has to simplify to 3/4. This could be 6 over 8. This could be 4.5 over 6. This could be 30 over 40. But whatever b and a are, their ratio simplifies to 3/4. So instead of thinking of b as 3, think of b as 3r, and then a as 4r, and then plug into the equation a squared plus b squared equals c squared. When you work it out, you're going to find the value for r as 2, and then you can find what b and a are. So we let b equal 3r, And if r is 2, now we know b is 6. And then we let a equal 4r, and if r is 2, now we know that a is 8. Now we have everything we need. So let's go back to the beginning. Remember, we know this is a vertical hyperbola, so that means we have this form of the equation, where the y squared term comes first. And we also know that b, and we know what a are, and we know the center is at 0, 0, so when you plug in all these values, you get the equation for your hyperbola. So that's example 2. Now let's look at the last example. Let's go ahead and look at example 3. So example 3 gives us this. So it gives us an equation, but it's definitely not in standard form. Looks like we'll have to complete the square, and we're supposed to find the vertices and foci. So again, pause the video, try this on your own, and we'll take a look at it here. Okay, so one thing that may be tempting, first of all, is that the y squared is positive. So you may be thinking this is going to be a vertical hyperbola, but you actually can't assume that by looking at this equation. You're going to see this one actually turns out to be horizontal. So don't go by this form and the y squared being positive. You have to wait until you get it into standard form. So let's see how this ended up flipping to the x squared being positive. So just like always with completing the square, you have to collect your terms together that you're going to complete the square on. So since the x and the y are both squared, we're going to complete the square on both variables. So we collected the y's together and then collected the x's together. Now, one thing you got to be a little careful here is I'm waiting to factor out the coefficient till the second step. You can factor it out right from the beginning. You can jump right to this line right here. But when I'm writing it like this, because I'm putting parentheses, I've already factored out a negative. So this 12x actually turns into a negative 12x. So just watch out for that. But then I can't complete the square until the coefficient is a positive 1. So over here I had to factor out an 11. So this turns into 4y. And here I had to factor out a 3. So this turns into negative 4x. And now we can complete the square. Half of b squared, half of 4 is 2. 2 squared is 4. So I added 4 here, but I really added 11 times 4, so I got to add 44 over here. And then over here, half of negative 4 is negative 2, but negative 2 squared is 4. Negative 3 times 4 is negative 12. I really added a negative 12 on this side, so I got to add a negative 12 here. And then we can factor. So this factors into y plus 2 squared. This quadratic factors into x minus 2 squared. And this all simplifies to negative 16. And then this is where the swap of the positives happen. I have to make this equal a positive 1, so I had to divide everything by negative 16. So I went ahead and switched these terms too, because when I divide this negative term by a negative 16, it's going to turn into a positive term. So I have this divided by 16, and then this positive 11 divided by negative 16. It's going to turn into a negative 11 over 16. And then this is like one of those ellipses problems that we saw. When I'm finding my value for a squared and b squared, I can't say that a squared is 3/16. I actually have to take the reciprocal so I can look at the entire denominator. And a squared is 16/3 and b squared is 16/11. So now I have it in standard form, so now I have everything that I need. So now, let me go ahead and scroll up here. So there's a lot of stuff happening here. It's horizontal because x is positive, so that means my vertices are going to be horizontally aligned, so it's all going to be about a. And then my foci are also going to be horizontally aligned. So when I find c, it's going to affect just the x coordinate. All right, so we know the center is positive 2, negative 2. I got that. If I take the square root of 16/3, I get 4 over root 3, rationalize the denominator, and I get that. And then b is the square root of 16 over 11, so I get 4 over root 11, again, rationalize the denominator, and I get that. And then, because it's asking for the foci, I need c. So I'm going to go back to this equation here and Gosh darn it. If only the denominators were 16. I need a common denominator here. So I'm going to use 33. And so I have to multiply 16 times 11. I get 176. I have to multiply 16 times 3 and I get 48. Combine them, I get 224 over 33. Now I got to take the square root. So over here I'm simplifying the square root of 224. I made a factor tree out of it. Once I made my factor tree, 14 is going to split into 2 and 7. There's no perfect square in there, but 4 times 4 is 16. So the square root of 16 is 4, and then I have the leftover 14. I still have my square root of 33, and then I multiply top and bottom by root 33. Over here I just quickly did 14 times 33, and I get this. And I'm also confident that square root of 462 will not simplify because I'm thinking about where that came from. 462 came from 14 times 13, or 33. If you make a factor tree out of that, then you're going to have 2 times 7 times 3 times 11. There's no perfect square in there, so I know that won't simplify. So there's my C. And then, to find the vertices in the foci, again, it's a horizontal hyperbola, so we're going to measure horizontally from the center. It's all about the x-coordinate. So from the x-coordinate, we're going to add and subtract A to get the vertices. And then for the foci, we're going to add and subtract C from the x-coordinate of the center. And there we go. So there's 3 examples in a nutshell, and you can try some on your own. Have fun.